Welcome, sixth graders, to virtual math class. I'm Mrs. Claus, and this is our first lesson of the year. So let's get started. We are going to be talking about integers today. Okay, let's present on. Here we go. Okay. So throughout the video, you're going to have some opportunities where the video will pause and stop, and you will be answering some questions about the material. So if you want to take notes or pause the video to take notes at any time, feel free to do so. So let's get started. This is going to be lesson 1.1a, identifying integers. And I want to get my spotlight. Okay. So our standards that we're going to be covering are: I can find positive and negative integers on a number line. And the full standard is written there below you. NS5 is what we're working on, number systems number 5. Understand that positive and negative numbers are used together to describe quantities having opposite directions or values. For example, temperature, above, below zero, elevation, above, below sea level, credits, debits, positive, negative, electric charge. Use positive and negative numbers to represent quantities in real world context, explaining the meaning of zero in each situation. Don't worry if that sounds really confusing to you. I would mainly focus on this here. I can find positive and negative integers on a number line. So let's get on with our lesson. I'm going to just minimize myself so you can see the full screen there. And let's go on. Okay, we got to start with a few definitions. A number line. What is a number line? Have you ever seen a number line when you were in 5th grade? Hopefully you have. If not, here's what a number line is. It is a line that shows positive and negative numbers spaced out evenly along the line. The number line helps you to add and subtract integers. So here's an example of a number line. And you can see that the numbers, I have my spotlight here, go both positively and they also go, that thing keeps showing up at the bottom there. Wait for that to disappear. They also go negative to the left. So positive to the right, negative to the left. And there you will see positive integers, 1, 2, 3, 4. And that arrow on the end of the number line indicates that it goes on forever and ever. So you can keep counting. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, all the way to eternity. That's how many numbers there are on the number line. Negative integers are to the left of 0. And they do the same thing. They count -1, -2, -3, -4, and you can keep going. -5, -6, -7, -8, all the way to eternity going the left direction. What about 0? 0 is neutral. It is neither positive nor negative. Some more definitions. You probably are asking yourself, what is she saying? An integer. What's an integer? Well, positive integers are those numbers there to the right of 0. They are numbers that are greater than 0. Positive numbers can be written with or without a plus sign. So for example, I could write +2, or I could just write 2. Both of those mean the same thing. Most of the time, you will not see the plus sign in front of a positive integer. So here's an example: 3, +3, 10, +10. Those are all the same number. 3 and +3 and 10 and +10 are the same number, the same integer. You can just see it written 2 different ways. Okay, let me clear my drawings here. More about positive integers. There they are again, our fun positive integers. And just so you know, I'm coloring them blue right now, just so you can get an idea and keep in mind which ones are positive, and then the negatives I'm making red. But eventually you're just going to see them all in one black color. So just helping you get used to the number line. The farther the numbers get from 0, the bigger the number. So for example, number 1 here is 1 unit from 0, but number 4 is 4 units from 0. 1, 2, 3, 4 units. So 4 is the bigger number, farther from 0. So for example, think of it this way. Would you rather have 1 hour to play videos, or would you rather have 4 hours to play videos? 4 hours, right? Why? Because you have more time. 4 is bigger than 1. So that's another way of looking at it. Positive integers get bigger as you go to the right, farther from 0. Now let's look at negative integers. And again, I'm making those red for now. They are the ones that are to the left of 0 on the number line. And they have a negative sign in front of them. They always have to have a negative sign in front of them. They can never be written without it. They are numbers that are less than 0. Negative numbers must always be written with the negative sign, as I stated. So for example, -3 is a negative integer, -5 is a negative integer, -10 is a negative integer, and -125 is a negative integer. You could go all the way up to 1,000,005 if you wanted, -1,000,005 or more. More about negative integers. There they are again, our negative integers. The farther the numbers get from 0, the smaller the number. So it's just the opposite from the positive integer. So if I'm at -1, I am closer to 0 than I am at -4. Notice the difference. From -4 to 0, I have to go all the way over here. From -1 to 0, I only have to go here. So -1 is closer to 0, so -1 is bigger and -4 is smaller. Just the opposite on the left side. So for example, think of it as temperature. Would you rather play outside at -1 degrees Fahrenheit or -20 degrees Fahrenheit? Well, I'd rather play outside at -1. Why? Because it's warmer. The number is bigger. So -20 is farther from 0 because -20 is probably somewhere way down here on the number line. And -20 is way farther from 0 than -1 over here. So you would say that -20 is smaller than -1. Okay, what's an integer? An integer is a positive whole number or a negative whole number. So they're like the counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Or the negative counting numbers, -1, -2, -3, -4, -5, etc. Integers are the numbers on the number line, but not the in-between numbers on the number line. For example, here's some integers, -2 and 2. Those are integers. All the numbers you see below you are integers. However, a number in between, like the 3 and the 4, is not an integer. What do you think that number might be between the 3 and the 4? Right. It's about maybe 3.5 or 3.5. It could be a little bit less, a little bit more, but it's not an integer because it's not a whole number. It's not a counting number. Okay, now it's your turn. So you're going to get a chance now to try out some of the things you learned with some questions that will give me a score at the end of the video. So I'll see you back in a moment. Okay, how did you do? I hope you did well. Okay, on the questions, let's go on to learn a little bit more about integers on the number line. There's a number line. Now I've made my number line a little bigger. You can see I've gone up to 10, both directions, positive 10, and then I went all the way to negative 10 on the left side. Positive numbers go to the right. Negative numbers go to the left. I want you to get real familiar with that concept. Positive numbers, again, get larger as you get farther from 0. Negative numbers get smaller as you get farther from 0. So keep that in mind. Where students normally make mistakes is on the negative side. So try to keep that to memory. In fact, that would be a good thing to do. Pause the video and write those notes down there. Positive numbers get larger as you get farther from 0, and negative numbers get smaller as you get farther from 0. That would be an excellent note-taking opportunity. Okay, let's move on. Number lines can be vertical as well. That's the up and down way. They don't just have to go horizontally. They can go up and down. Have you ever seen a thermometer? There's a thermometer, right? That is like a vertical number line. It's a number line turned to the up and down way. A thermometer is a vertical number line. And I put next to it a number line. You can see that a number line can be turned. And notice how the numbers that are positive go in the up direction, and the numbers that are negative go in the down direction. So keep that in mind. If you think about it later on in the year, we're going to be covering a coordinate plane and a coordinate graphing, and we're going to be finding points that go both up and down and left and right. So we're going to have to know the up and down number line as well. So you can use temperature to think of which numbers are greater and which numbers are less. Which is a greater temperature, positive 5 or positive 20? Think about that. Which one would be the greater temperature? Well, obviously positive 20, right, would be bigger because it's farther from 0 going in the up direction. How about this one? Which is a greater temperature, negative 5 or negative 20? Again, think about what temperature you would rather play outside at. Right, negative 5 is closer to 0. Let's go circle that on our number line. Negative 5 is closer to 0 than negative 20 over here. So let me just change colors here. Negative 20 is from here to there. Negative 5 is only from here to there. So notice that negative 5 is closer to 0, and negative numbers that are closer to 0 are the bigger numbers. So the greater temperature is negative 5. Have you ever heard of the word elevation? Elevation describes your height above or below sea level. So we can put another vertical number line there, and we can say that sea level is at 0. So there's sea level, and there I drew a little bit of a C. That's supposed to be the C. So sea level is always considered 0. Wisconsin is pretty close to sea level, whereas Colorado with the big mountains is very far from sea level, right? Because they have very high mountains. So elevation is how high off the ground you are from the sea. Elevations above sea level are positive, and elevations below sea level are negative. So you can say you're 50 feet below sea level. That means you're 50 feet under the water. Or you could say you're 10 feet below sea level. Then you're 10 feet under the water. You could also say you're 10 feet above sea level. That means you're 10 feet off the ground from where the sea starts. Okay, there's above sea level. There's mountains. As you go higher and higher in elevation above sea level, you can get up into the very high mountains. And then below sea level, you see my little scuba diver here at the bottom, because that's underneath the sea, right? So below sea level, you're under the water. Okay, let's keep our little number line there. A diver is 20 feet below sea level. What number, think about this, represents the elevation of the diver? How would you write the number that the diver is 20 feet below sea level? What would you write there? How would you show that? Did you say negative 20? You did. Great job. That's exactly right. Awesome. Can't fool you guys. Number 2, which integer is closest to sea level? Here's your choices. Which integer is closest to sea level? Closest to 0. Well, let's look at the 4 choices that we have. We have negative 20 right here. We have negative 5 right here. We have positive 15 over here. And then we have positive 72, which is going to be somewhere up in these mountains, right? Doesn't show on our thing. So which one of those numbers is closest to 0? Can you tell from the picture? Exactly. Negative 5 is the closest number to 0. So let's see if you got it. Take away the ones that are not the answer. So negative 5 is the closest number to sea level. Which 2 integers are the same distance from sea level? The same distance. Here are your choices. Which 2 integers are the same distance from sea level? Well, which one do you think we can eliminate? Yep, 7, isn't it? What's the next one I'm going to get rid of? Right. So negative 11 and positive 11 are the same distance from 0, just on different sides. So for instance, positive 11 would be somewhere right here after the 10, and negative 11 would be right below the negative 10. And they would both be 11 units to sea level. Both of them would be exactly identical, 11 units. Okay, we're going to make them spin. Which integer has the least elevation? The least elevation, the smallest elevation. Which one is the least highest from the ground is another way of saying that. So do you think negative 6 has the least elevation? Where would that be on the number line? Negative 6. That would be maybe about, let me get a drawing tool here, right after the negative 5, right below it. That's about negative 6. Positive 8, that's going to be past the 5, but lower than the 10. So that's about somewhere in here. And then negative 3, that's going to be before the negative 5, right? That's going to be about here. And then you have negative 9. Well, that's going to be below the or above the negative 10, but below the negative 6, right? So somewhere in there. So which integer has the least elevation? Which integer is the farthest below the ground, below, as far down as you can go? Which one's farthest down on the number line? Did you say negative 9? Let's see. Get rid of all the ones that it isn't. There it is. Negative 9 is the answer. That one is below sea level the most. Negative 6 is higher, negative 3 is higher, negative 8 or positive 8 is way higher, right? So there you go. Okay, now it's your turn to give some of these questions a try. So go ahead and I'll see you back in a moment. Okay, how did you do? Great. Okay, let's go on from there. We're going to talk about graphing points on a number line. So we're going to graph negative 1 on a number line. So here's our number line. Now notice how I didn't make the colors of the number line red and blue anymore. Now they're black. Where would negative 1 be found? There it is, that red dot. Okay, graph 10 on the number line. Where's that one going to be? Is it going to be to the left of 0 or to the right of 0? Did you say to the right? Excellent. There it is, that blue dot. There's 10 on the number line. Graph a number 7 units to the left of 0. 7 units to the left of 0. Well, here's my 0. I want to go 7 units left. Left is that direction, right? So let's count. 1, 2, 3, 4, 5, 6, 7. Would it be at -7? That's where I landed, right? Let's see. There it is, -7. That's the number 7 units to the left of 0. Graph a number 3 units to the right of -2. 3 units to the right of -2. Well, where's -2? That's right here, right? And we want to go 3 units this direction now, 3 units to the right. So we're going to start at -2 and we're going to count 1. Count the jump as 1. Don't count until you jump. 2, 3. What did we land on? We landed on 1. So a number that is 3 units to the right of -2 is 1. See if we can put our dot in there. There it is, our blue dot, 1. Okay, let's go on from there. Okay, we're going to do some focus on higher order thinking. These are problems that are making us think a little bit harder. Okay, we have the highest and lowest places in the United States. Believe it or not, they're both in California. Mount Whitney is the highest spot in California. It's, you look here, put a circle around it, it's 14,900, I want to make that red. 14,909, let me try that again. 14,495 feet above sea level. Death Valley in California is -282 feet below sea level. So it's actually lower than the sea. Okay, now what's our question going to be? Now that we know what the graph says, let's see. There's sea level. Notice how Death Valley is below sea level. It's a negative number. And look how much higher Mount Whitney is than sea level. What you'd expect for a mountain. Use the graph to find the difference in elevation between Mount Whitney and Death Valley. The difference. Well, let's think about this. We know for sea level, we know is at 0, right? So if we go from 0 all the way up, how many units have we gone up? Well, we've gone 14,495, I think that's feet up, right? From the 0. Okay, what if we go to Death Valley? How many feet down have we gone from 0? 282 feet down, right? So how are we going to figure out the difference between the two? How are we going to do that? Let's take a look. Well, we're going to start at the lowest point. I'm going to clear my drawing here. Start at the lowest point, -282, and we knew that that was 282 feet to the 0. We're going to go up from the lowest point to sea level. I'm going to draw that back on there now that I cleared it. We went from here to here. This was 282 feet. And then we're going to go up from sea level like we did right here, trying to draw it. Not very straight. And we went up 14,495 feet to the top of Mount Whitney. So to figure out the whole difference, we're going to add the 282 feet we went to get to 0, to get to sea level, plus the 14,495 feet we went from 0 up to the top of the mountain. If we were to add those two numbers together, we would get 14,777 feet. Remember how to add numbers? When you line up the numbers, you have to line them up by columns, right? I would have to do this vertically in order to figure it out. 282. Remember, you got to line your ones column up You got to line your tens columns, your hundreds columns, etc. So 5 plus 2 is 7. 9 plus 8 is 17. Carry my 1. 4 plus 2 is 6 plus 1 is 7. And then 4 and nothing is 4. And 1 and nothing is 1. So that's where we get the 14,777. Okay, now it's your turn to give it a try. See you back in a minute. Do your best. Okay, we're at the end of our lesson. I'm going to come back on the screen, hopefully. Here I am. Okay, and this is going to be your homework. I want you to do IXL. There's a thing called integers, and you're going to be doing understanding integers. You're going to be doing integers on the number line. Should be number lines, number lines. Graph integers on horizontal and vertical number lines. You're going to practice that. I would say on IXL, there's probably about 20 to 30 questions that kind of you zip through real quick. And then math book, I want you to do page 7, letters A, B, C, D, and E. And then I want you to just do the top of page 8, numbers 1 and numbers 2. So not too much in the math book right now. Next lesson you will. So page 7, A, B, C, D, and E. And then the top of page 8, numbers 1 and 2. And then the IXL practice. So let me stop my share here. Okay, I'm back. So have a great day, and we will see you at the next lesson. Bye.